Pi black box valve amp someone sent to me to service. Luckily online there's a circuit diagram, so I won't have to draw it all out. This is a 4-valve version. I think there's a 3-valve version as well. So it's got, according to this, EL42s in push-pull, drive-in through, still use their nice feedback on the transformer, which is good. Valve rectification, volume control, and there's the control for the tone somewhere. Anyway, it looks pretty straightforward. I'll check out all the valves and the components and clean it up, and the capacitor have to be checked, and see if it works. The first problem is that this potentiometer, which is the volume control, it broken inside. This shaft, which is very long, it was pulling out, and when it pulls out, it stops the mechanism. It's coming apart. What happened is that this little mechanism which fitted in there, and also turned the bottom part, it's a jewel, I think it was supposed to be like riveted on, and it's come off. Well, I could try gluing it, but that might still not be much good. Luckily I have another one which is taken out of a piece of equipment, and this potentiometer is the same. The circuit's slightly different. This one's got a dual capacitor here for smoothing. This has only got a single and an extra capacitor put in to give you the two capacitors. The rest of the circuit is very similar. This other potentiometer, which is the on-off switch and the treble control, someone had disconnected it. The wire had been disconnected because it had gone all crackly, and I used a lot of like contact cleaner, spraying it into the gap there and turning it backwards and forwards, backwards and forwards until I started getting a reading. Normally that's good enough. I find that you don't have to replace the pots if you clean them up like that. This one's got the on-off switch. Luckily the on-off switch isn't broken. I've seen broken ones. So I can rewire that back in, but this part I'm not going to try and fix it. I will take it out. I'll have to take this one out here. It's a dual 1 meg, giving you 2 meg resistance to the ceramic cartridge, and the linear pots, I don't know why they couldn't have used exactly a 2 meg one, but I don't know why they do some of these things. The rest of the components, I've been checking them. Might have to change a few capacitors. This dual capacitor actually tests okay. I've checked the capacitance and the ESR, but I'll just continue. I'll fix this pot first. Continuing to service this little lamp, I've put the potentiometer in. I took out this one, so I put in here. I've also rewired this after cleaning this treble pot. Someone had disconnected these wires because it was obviously going all crackly in open circuit, and they'd cut these wires off. So I've cleaned it and it's working now, and I've put the wires back on. I've rewired this pot. I've been checking the capacitors and resistors around there. Just checking around these valves here. I've been drawing out the circuit. The circuit's not exactly the same as the one that was downloaded offline. The input is totally different. This only had one pot, and this has got a pot with a capacitor and resistor, which affects the treble as the volume is turned down. It cuts some of the treble. The 100k goes in there. On this one, it only had 1k, and it had a bleed resistor for the grid. This one uses the pots to bleed away any voltage. So hopefully, if these ever go open circuit or crackle like anything, the feedback from the speaker comes in here. Totally different values. There's a 10k and a 2.5k pot, which acts as a treble cut. With the feedback, it's like a tone control, which was not on the original circuit at all. They had some feedback from the speaker. Values seem okay. I've cleaned this pot. It was open circuit before. Now it should work. I haven't quite finished this bit. It feeds off of there, 220k. The capacitors, there's a 25 and a 12 microfarad in the can. They test alright. Comes through the 27k, which is okay. Now, the output, as I said, it's a push-pull. Okay, checking over the circuit. There seems to be a manufacturing fault with this unit that was sent to me for servicing. This is a push-pull circuit, 2 valves. Push-pull the signal into the transformer. It's normal practice. You connect the 2 cathodes together through a resistor to ground, which sets the voltage for the signal and the amplification, everything. 470 ohms. They share it, which is fine. Sometimes there's a bypass with a capacitor. It gives you more gain, but they've obviously got enough gain. Well, here's the 470 ohm resistor, and there is a connection to one of these. Are the two valves, those two, and it's connected to that one, which is, I've drawn out the base here. That is the cathode. It's counted round. It's one. That's number 1 there. 1, 2, 3, and it's connected to ground. 470 ohm, and that anyway. I will be checking the valves. I've got all the valves. I just put them in there. I'll test them and put them in, and I'll be powering the circuit. I'll connect. I've got my dummy load and everything up there. There's some information on this transformer, by the way. It says 1.5 ohms on the speaker. Just checking the valves. EL42. I've set the AVO Mark III according to the book. Settings here, and it says should give 26 milliamps and 3.2 milliamps per volt. Look at that, it's nearly spot on. It's just about 26 milliamps, and if I just turn the scale like this to get the milliamps per volt, set that to 0. Turn that, set that to number 1, outer scale. No, that's close enough. It's about 3.4. That's just better, which is even better, considering that this isn't 100% accurate. That's so close. After all these years, that valve is absolutely still Mullard valve. Was so well made, it's still giving it the exact reading it should do. So I just I've already checked the EZ41 on there, and that was perfect as well, Mullard. I'll just check the other EL42 and the ECC83, which I'm sure will be fine, and we put them back into the amplifier. Finished checking all the circuit over. I've had to replace nothing really. Most of these resistors are pretty close, and some of them aren't that critical, so even if they drifted a little bit. Capacitors test fine. I will monitor them in case they break down at voltage, but I think these ones are quite good and they're not going to short out when I apply the volts. I did notice that they hadn't wired the cathodes together, or the screen, till I realised on the EL42, the Mullard ones anyway, are wired inside. The screen is wired to the cathode, actually inside. So if one of them, the two screens were connected together by a wire, and because it's, when you plug it in, it's connected together, and that one's connected together, they're all connected, you wouldn't need the external wire. But I put it in anyway, because if you buy another valve that's not made by Mullard, they may not have connected it inside. Not all of them do. And it was only a little bit of extra wire, and I noticed on this one, it was connected anyway. So for a little bit of wire, and I did it just. So I'll ramp up. I'll put the valves in, which I've tested and all fine, and ramp up the voltage, checking the circuit as it goes up. By the way, this bulb, it's nice and white, is basically a 6.5 or 6.3 volts. The one on this one's gone exactly the same, completely white. Yeah, you can buy these bulbs, I haven't got around them, but 6.5, 10 millimeter, and 300 milliamps. Those ones you want. They're dead cheap, and I'll just screw one in there. Okay, I'm going to connect it up. I put a load on, a dummy load on the speaker, and just so I can check the voltages before I put some sound to it. I've slowly ramped up the voltage to about 235 volts. Current draws about 0.2 or less. Checking some of the voltages on the circuit diagram. I'll check the voltage out of the rectifier and then the voltage after this dropper. So after the rectifier we got 256 volts. There's 232 volts after the resistor. On the cathode resistor, the EL42 outputs got 16 volts, which is good. And I've also measured the voltage at the phase splitter. Probably see it easier on there. The phase splitter there, because you've got 57k to phase split. Just checking that voltage there, and it's 21 volts, which sounds okay. I've got a speaker connected, but I can't hear any sound from it. I'm going to put a signal generator on it next and see if we can get some sound out of it. Right, I'm feeding in a signal into the amp, which is running. I've got the dummy load 4 ohms. There's a monitor speaker on there, just turn it down a bit. And I've got the scope showing, we're feeding in 1 kilohertz. Input, I've got the scope on the input coming in from the SIG generator, and an input going out, one onto the output to the speaker. Yellow one is the input, 100 millivolts per division, so it's 1, 2, 3, 400 millivolts. To the speaker it's 1 volt per division, so you've got 1, 2, 3, 4, 5, 6 volts going out. And on the speaker I've also put this AC meters reading 1.85 volts, and on the graph that I've made, 4 ohm load, 1.85 volts is down here on 4 ohms. It's not quite 1 watt, so not very powerful. And if I turn the volume control down and up, keep turning it up, let's get a bit more output on there. Turn it up. There, it's peaking out. So the circuit's working nice. It's peaking out on the top and the bottom. So that's about maximum output it can give at 1 kilohertz. 1, 2, 3, 4, 5, 6, 7, about 8 volts peak to peak. 2.5 volts into 4 ohm load. So you've got your volts RMS. 2.5, 4 ohm load. got 1.5 watts. Now the tone control is oh, I turned it off. If I turn in the tone control up, it's driving and turning it down. So I just turn the volume down, turning the tone control up. It's actually increasing the 1 kilohertz level. That's peaking out, turning it down, up and down. So it's affecting about 1 kilohertz. Turning the frequency down on here to say 100 hertz. Let's see if, again, it's not distorting at 100 hertz. Turning the tone control, having no real effect at 100 hertz. Let's try it at 10 kilohertz. Turning the tone control, turn it up. So it gives a little boost to high frequency, turn it down. So it's not doing bad at 10 kilohertz. Still giving you 1, 2, 3, 4, 5, 6 volts. Just under 2 volts. So it drops a little bit on the power. 2 volts. 4 ohms, about 1 watt. Let's turn the frequency down so we can hear it. It's about 5 kilohertz. Try the tone control. Tone control does up and down. 500 hertz about. Tone control up, down, has a little effect. So I don't know, tone control acts a bit like a secondary voltage, but I mean, you know, that's as much as you can get out of it. About 1.5 watts. So it's working. That's about all I can do, really. Can we boost the power a bit? Could try bypassing the cathode resistor, see if it can take it, or depends where it's hitting the voltage max. Anyway, there you go. Okay, I've connected it up to a mono record player or garage. I've connected up some speakers. These combined are only 8 ohms. This is supposed to run into 1.5 ohm speaker for maximum output, but 8 ohms to check that it's working. So it's mono, so let's just put this record on. This is old 78. Check the volume. And this other control, not sure what it's supposed to do. It cuts the treble a bit, but it's working as per the circuit diagram, but it doesn't do a lot. But into 1.5 ohms it probably sounds a bit better. Okay, so that's all working. Just got to put the bass back on it and be fine. Goes quite loud. Small garage X 78. Flying around. Okay, that's done then.